Okay, in example 421, we're going to model exponential decay using the function or the equation y equals a e to the kt, where a is the initial amount, k is the decay amount, and t is the time in years, and then y is the amount present at time t. Okay, so a fossil contains 2 grams of carbon-14. The question is, will more than 1.5 grams of carbon-14 remain in the fossil 1,000 years from now? And you're given that the half-life of carbon is 5,715 years. Okay, so if we use this equation, we know that at time 0, the initial amount y of 0 is a e to the k, which we haven't solved for, t, but t is 0. So that gives us that the amount of time 0, which we said was 2 grams, is a, e to the 0, or just a. So we solved at time 0, we solved a equals 2. Okay? And then we know that after 5,715 years, we have half the amount we normally would, because the half-life is 5,715. So that means that 1/2 a equals a e to the k, and then you plug in 5,715 for t. And this will allow us to solve for the rate of decay, k. So we divide both sides by a, and you get 1/2 equals e to the 5,715 times k. We'll apply natural log to both sides to get rid of that e. And so you're left with the natural log of 1/2 equals 5,715 times k. So k is going to be equal to the natural log of 1/2 divided by 5,715. And I'll plug that into a calculator real quick. We get, let's see here, ln of 1/2, and then divided by 5,715. So you should get, this is about negative 0.0012285596. So that's more than enough decimal points there, but that's our constant k, or rate of decay. Okay, and now that you have that, now we can figure out how much of the carbon-14 will be left in 1,000 years. And so we take y of 1,000, that will be 2, because a is 2 there, e to the negative 0.00012128, just round off there, or I guess 6, let's say, and then times 1,000, because that's after 1,000 years. So then you get that y of 1,000 equals 2e to the negative 0.121286, because 1,000 times something with 3 zeros out in front will just shift everything over 3 units. Okay, and so when you plug that into a calculator, what do we get? 2e raised to and I got 1.77. So the amount left after 1,000 years is approximately 1.77 grams. And so the answer is, will more than 1.5 grams of carbon be remaining after 1,000 years? And the answer is yes. In fact, there'll be 1.77 grams left after 1,000 years.